Hello everybody. This is the first of 4 videos that you are going to watch for derivative rules. Please have your packets out and turn to this page. This page is number 16, I believe. I think it's 16. I think it is. It is. And you can cross off the discussing average velocity and instantaneous velocity. We are not going to do that in this video or any of the 4 videos. We'll discuss that during class. But in this video, though, we are going to go over a constant rule, and the power rule, and the constant multiple rule, and the sum and difference rule. And in the next video, we'll go over sine and cosines. So, let's go ahead and get going. Okay, so we have shortcut rules for differentiation. The shortcut rule, if you're not sure what I mean by shortcut, that means no more limits. We do not have to use limits to find derivatives. And for those of us that have only seen derivatives through limits, you're going to love this part. Because this part just means that all that long difference quotient stuff that we've been doing before, this whole f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. That's out of here, man. That you do not need to worry about until August, April, May. We'll revisit that in May and April. Now, for those of you that have not had me as a teacher, and for those of you that have not seen my handwriting, it's bad. Jay likes to point it out over and over again in class. He's polite, but he's also kind of mean about it. I've cried a little bit a couple times. I'm working on it. I'm working on my handwriting. Okay, constant rule. So let's go over the constant rule. And again, you've seen a video on this already. This is just more officially. The constant rule, the derivative of any number, 0. The derivative of any number that you have, just by itself, no x's attached to it, no sine x or anything of that nature, just the derivative of any particular number is 0. The derivative of the power rule. Well, we've done that before in this class during our summer videos, is n times x to the n minus 1, and n can be any number you want it to be. Any number. And again, basically what happens here, we explained in the previous video, is the n drops out in front, and then you just subtract 1 from the exponent. Okay, the constant multiple rule. Well, this is going to be pretty straightforward. The constant multiple rule for this power function is going to be c times n times x to the n minus 1. There's nothing really fancy there. Basically what that means, and if I didn't say it already, if you haven't heard this, ddx stands for take derivative of. So to take the derivative of a function that has a number in front of a power function, so a number like 5 times, let's do x to the 4th. The way we do this, to take the derivative, no more limits, do not do a limit. We've reached our limit with limits. Horrible. So we're going to go ahead and do 5 times 4. So we're going to drop that 4 down. The green 5 is staying there. We're going to do 5 times the 4 comes down in front. The power function is still there. X to the 4 minus 1, which is 3. And if we simplify, we get 20x cubed. So that's what we mean by the constant multiple rule. The coefficient just stays in front of the function. You wait until we deal with it until the very end. Okay, the sum and difference rule. So if we are adding or subtracting 2 functions, and we want to take the derivative of that sum or difference, well, your derivative, remember this means take the derivative of the sum or difference. When we take the derivative of the sum and difference, we get f prime plus or minus g prime of x. That's it. Nothing else. So basically, you can distribute a derivative to a sum and difference. That does not work in product and quotient rules. When you have a product of 2 functions or a quotient of 2 functions or a composition of functions, there's different rules for those. So this only works distribution for derivatives only works when you have addition and subtraction of functions. So let's try some of these now and see if we got this. This is a power rule. This is a power function. I didn't say it earlier, but a power function, I'm just going to write this down because this is good for you to know. A power function is when you have x to a number. You're going to have exponential functions later on where it's a number to x. So the derivative of this power function, you're welcome to pause the video and try all of them if you want. 1, 2, 3, 4, 5, and see you can get 5 in a row. I bet you can. I bet you can. All right, that's enough of that. I have a 3-year-old at home. Sometimes I get too silly and sometimes I just can't control it. The derivative of x cubed, 3x squared. The way I got that, 3 drops down in front, drop the exponent by 1, I get a 2. For the second one, 1 over x to the 4th. Sorry. 1 over x to the 4th, I'm going to rewrite that actually as d dx of x to the negative 4. Because I want to see what the exponent is. The exponent isn't really a positive 4, it's a negative 4. And now when I do that, power rule again, negative 4 to the x to the, this one I'm going to write out, negative 4 minus 1. That is negative 4x to the negative 5th, or negative 4 over x to the 5th. A negative exponent just sends the variable to the opposite side of the fraction, so it's on the bottom. And negative 4 minus 1 is negative 5. We have a lot of students here that, we've had a lot of students in the past that have thought that negative 4 minus 1 is negative 3. Please be careful with that kind of problem. Please also look at what happens if you keep taking derivatives out of this over and over again, because you'll find a pattern. So what happens after successive derivative? I won't answer that for you in this video. I want you to explore that on your own, because if you can find a shortcut for these, oh man, it's going to make your life way easier. So what pattern exists for these? And again, what I mean by that, in case you're not sure, is so now what's the derivative of negative 4 over x to the 5th? And then after you get that answer, then what's the derivative of that one? Because again, you should start seeing a pattern in how the and what's going on with the derivatives. There's a little pattern for those. Okay, the fourth root of x. I'm going to duplicate this page and clear it out because now it's starting to get a little ugly. So let me clone this guy. Let's go ahead and clear the ink on this guy. Let's go ahead and scroll down. Okay, here we go. Okay. The fourth root of x. That is also known as x to the, go ahead and say it out loud. Loud! Good, x to the 1/4. It's very good. I heard somebody say it out there. I'm actually in the math office right now, but as somebody was walking by, I heard someone say 1/4. I was like, yeah, good job. Okay, so we had x to the 1/4. So let's rewrite our derivative. Derivative of x to the 1/4 is what we're looking for. It's a power rule. So we're going to drop the fraction down in front. So we have 1/4 x to the 1/4 minus 3. I'm sorry, minus 1. That's going to be negative 3/4. And we can usually leave our answer like this. We don't have to rewrite it anyway. You could, if you want, write your answer as such. But I mean, like, who would want to do this? Oh, oh, God, I almost got nauseous looking at that thing. The top one is way better than that. All right, just leave your answer in a with a negative exponent. But, and I tell my students this always. In your homework, though, you keep practicing over and over and over again, simplifying things or rewriting the expression, because what the AP test does is it likes to get you to apply a rule, and you're going to do fine on the rule, but then their multiple choice answers won't be one of the answers that you have, and they're going to require some kind of simplification on your part. So my tips has always been to students, practice your simplifying on your homework. Make sure you're mastering those algebra rules. That way you can actually manipulate your answer once you do the calculus to get the answers in the multiple choice, if that makes sense. Let's pick up the pace here. The derivative of this one, we can take the derivative term by term because we're just subtracting each one. We don't have a product of two functions. We don't have a quotient of two functions, just a function and a function and a function. Final answer here, derivative of x squared is 2x. The derivative of negative 2x. So the derivative of negative 2x, well, it's negative 2x to the first. You drop that exponent down, you get negative 2x to the 0. It's just negative 2. This should make sense, by the way, that the derivative of negative 2x is negative 2, because on a line of negative 2x, the slope at every one of these points is negative 2. You don't have to do that for a problem. I'm just giving you extra information. And the derivative of a constant, oh, I love these. The derivative of a constant, something like negative 3, that's 0, man. So 2x minus 2 plus 0, or just 2x minus 2. Okay, last one. Derivative of pi over 3x squared. Ugh. Ugh. Gosh, that looks horrible. Let's rewrite it. Pi over 3x squared. Notice how when I approach these problems, I actually don't jump into the derivative right away. And I'm going to repeat that because that's important. I do not jump into the derivative right away. I'm actually looking at the problem and seeing how I can rearrange it, because sometimes when I rearrange it, I actually will have an easier time taking the derivative. So for instance, for this one, I see this one as pi over 3 times x to the negative 2. Way better. Way better to take the derivative of. So now, I do d dx. Remember, d dx means take the derivative of. I'm doing d dx of pi over 3x to the negative 2. That's a power rule. Pi over 3 is just a coefficient. So I'm going to do, this is equal to pi over 3 times negative 2 times x to the negative 2 minus 1, which is negative 3. Final answer here, I get negative 2 pi over 3. And again, if I want to put that x to the negative third in the bottom, that's fine, because I should practice that when I'm doing homework. But either answer would have been fine here. And yes, I did say either answer would have been fine here. You did the calculus. That's the answer. Thank you for watching the first one.